Hello, welcome to The Naked Scientist with me, Hannah Critchlow, and with Chris Smith. Hi, Chris.
Hello, Hannah. And this week, why India and America are both launching probes to Mars within a few weeks of each other. We'll find out where the meteor that hit Russia in February came from. Plus, we're talking multiple sclerosis this week, what causes it, how the US TV show The West Wing offered hope for one sufferer, and some new treatments that might mark a breakthrough in reversing the damage that's done by the disease. You're listening to The Naked Scientist with Chris Smith and with Hannah Critchlow.
And on to our main topic for the week now. Multiple sclerosis. It's a debilitating disease which affects more than 2 million people worldwide. It commonly strikes otherwise healthy individuals in their 20s and 30s, and the symptoms can include loss of sensation and difficulty moving. Many sufferers can become wheelchair-bound. To find out what it's like to have MS, I went to see someone who was diagnosed with the disease 10 years ago.
I'm Anthony Dean. I was diagnosed with MS in 2003 after a year of symptoms that were kind of similar and kind of strange, and I didn't really know what they were. I went to see my GP after having pins and needles in 2 fingers in my right hand, which went away after about a month. 3 months later, I had pins and needles down my left arm, and then about 6 months after that, I lost sensation in the right-hand side of my body from the neck down. So I had no sense of touch, found it difficult to hold things, to use a knife and fork. Work, typing was difficult. And that's when I went to the GP, who then referred me on to Addenbrooke's to be checked over for MS.
And that must have been quite terrifying to have experienced this almost paralysis. What happened once you were at Addenbrooke's hospital?
Went through a series of tests first, checked my vision, checked my balance, checked memory and sensation, touch. Then after that went back for a lumbar puncture, and then after the results of the lumbar puncture, that's when I got my diagnosis.
And how long did it take until your final diagnosis?
From my first symptom, which would have been 2002, I was diagnosed in July 2003, so just about a year from the first time it happened. But the first time it happened, I never told anyone, because to me it was just numbness in my fingers. I slept funny. I might have trapped a nerve, was what I told myself. When it happened the second time, I thought I trapped a nerve the second time. When it happened the third time, I thought, well, this is probably connected, and now it's probably time to go and see someone.
And at this point, how was it affecting your life whilst you were waiting for the diagnosis?
I was working at the time. It was more of an inconvenience. There was nothing that was stopping me from actually doing anything. At work, I ended up working one-handed, so I could use my left hand, but my right hand really couldn't control a mouse. I ended up typing with one finger on my right hand compared to using the whole of my left hand. And driving a car was not impossible, but there would have been times where, looking back now, perhaps I shouldn't have done it because I may not have felt that I had full control over the accelerator pedal. But it wasn't too bad. I was lucky in that sense that I could continue doing everything that I normally did. Perhaps wasn't playing golf as I used to, or playing snooker as I do. But yeah, everything else I could just about do.
And how did you feel after you were diagnosed with MS, all the way back in 2003?
At first, to hear a diagnosis like MS, it's a little bit startling. My only experience of MS, or anyone with MS, had actually been from the TV programme The West Wing. In the first series of it, it's revealed that essentially the American president has lied to the American public by saying he's had MS and he's been treated. In it, there's lots of questions over, is he capable to still be president? What happens if he has a relapse? Something which they actually spell out very clearly in the programme, that it's not a condition that will kill you. It's not something that is, it will affect you in certain ways, but it's not a life-threatening illness. So in it, he basically continues to be president for another 7 years after that point. So I felt very comfortable on the back of that.
Thanks to Anthony Dean from Cambridge.
It's interesting because he was talking about the West Wing and things like that, but someone else very famous who describes having had these same sorts of symptoms but knew what was happening to him because he was a medical student at the time. That was Michael Crichton, who wrote Jurassic Park. Mm-hmm. Yeah, he was one of the lucky ones, though, because he didn't get progression of his disease. He just got an episode and it luckily went away and didn't come back.
Oh, that is lucky. That is very fortunate.
Well, we just heard from Anthony a bit about what it's like to actually have the symptoms of multiple sclerosis, but what's actually going on in a person's body when they've got those symptoms? Alistair Compston is from the Department of Clinical Neuroscience in Cambridge, and he specialises in dealing with this disease. Hello, Alistair.
Good evening.
When someone has multiple sclerosis, what is this disease?
Well, Anthony's gave a very clear account of the experience for a patient of attacks which come and go with good long periods in between in which the patient is entirely well. What he was describing was the patches of damage occurring from time to time in his brain and spinal cord. And in those patches, a number of different things are happening. There's inflammation. There is some loss of the myelin sheath, which is found around most nerve fibres in the brain and the spinal cord. There's damage to the nerves themselves. There is sometimes some repair and remyelination, which we may hear about later, and there's scarring or sclerosis in those patches. So multiple sclerosis, lots of areas of scarring, and the problem has been to sort out what's driving that process and how those different components fit together.
What is causing the inflammation?
Well, this has been debated for many years, and it's only really recently that I think most people would agree that inflammation is the primary process, the one that is driving the disease. And that comes from the circulation, from the lymphoid organs. It's not something which starts in the brain. What triggers it is complex, and we'll probably discuss later some of the ideas around the causation of this inflammation, this autoimmunity, which most people would now accept drives the disease.
So the immune system, for some reason we don't quite understand, moves into the nervous system and begins to attack certain patches of the nervous system, but by no means all of it all at once.
Yes, that's the idea. And when that consensus was reached of thinking, then of course it did offer the possibility of trying out treatments which might stop the immunological, the inflammatory process, and so be useful for individuals who had the illness. But those ideas and the drugs which have been used really only started to come into play in the early 1990s. Since then, a number of drugs have been licensed and are used, and really multiple sclerosis has been a fantastic success story in terms of the menu of drugs which can be thought about and used by comparison with many of the other diseases of the nervous system that we as neurologists deal with on a daily basis. So it has been very successful, but of course there are still unmet needs and problems yet to be sorted.
So the way that you chiefly tackle the disease is to try to damp down or turn off the immune response, at least temporarily, when it tries to flare up, in order to stop it damaging the brain or spinal cord wherever it's damaging at that moment.
Well, that's my approach, and I think most people would now agree that to tackle the immunological component is a very good way to start, both from theoretical reasons, from what we know about the mechanisms of the disease, and also empirically from seeing what actually happens to patients when that approach is taken. So all of the drugs that a neurologist can now think about using in people with multiple sclerosis are orientated around the immunological component. That's not to say that there aren't other aspects of the mechanism of the disease that we would like to deal with, neuroprotection, remyelination and repair that we may hear about, but at the moment the licensed drugs are addressing the immunological component because we think that is pivotal and driving everything forward.
Is that what led you to try this fairly radical drug, Campath, which was invented here in Cambridge, which is a very potent way of removing the immune response, at least for a period of time, in some of your patients, like Anthony?
Well, when we first thought about using that monoclonal antibody, Cambridge pathology first human, Campath 1H, the logic was that, yes, the disease is immunologically driven, but dealing with it once it's started and trying to unpick the events going on within the central nervous system was bound to be difficult. And so our hypothesis was to ask whether we could go back a step and get outside the nervous system and deal with the process before the cascade of events had really set in. So the opportunity arose to do that because Campath is a humanized monoclonal antibody which targets the CD52 antigen, which is present on all immune cells, T and B lymphocytes. It could be given by intravenous injection, and there was every reason to expect that it would radically remove the immune system from the bloodstream and lymphoid organs, and then subsequently allow a repopulation with new cells, which we hoped would not bring back the old story of multiple sclerosis.
And is that what you found?
It is actually what we found, and we had to learn a number of lessons. It's taken us 25 years to get to the European licence, which was granted on the 17th of September this year. We learned many lessons along the way, but we've ended up with clear evidence that the efficacy, in other words, the usefulness of the drug, is very high. However, as with many treatments in medicine, and multiple sclerosis is no exception, there is no free lunch. And so with the very high efficacy comes significant risks and hazards and inconvenience of having to have injections and to attend hospital and to take part in risk monitoring schemes.
So just very briefly, in someone who has MS and it was progressing in them, you put them in your CAMPATH trial, what proportion of them are likely to achieve resolution of their disease like this, and what sorts of side effects might they expect?
Well, not quite, and we have to be careful with this word progression. So multiple sclerosis starts with episodes which come and go, and then later, after some time, usually many years, those episodes dry up, reduce in frequency, and are replaced by slow progression. We, in fact, began by treating people with progression, with advanced disease, who were already very disabled, and we learned after a number of years, 7 or 8 years, that this particular drug and all others are not useful in that situation, disappointingly. And so in 1999, we switched to treating the disease very early in people who were threatened by multiple sclerosis but were still relatively well. And it was that switch from treating the disease late to treating the disease early that was the crucial step. And now that we do that, the experience is very good for most patients.
Alistair, thank you very much. Alistair Compston from the Department of Clinical Neuroscience in Cambridge. He's with us for the rest of the programme, so if you have any questions about MS or the trial he was discussing, you can tweet at Naked Scientist. Hannah.
So, according to Alistair, the drug CAMPATH offers hope to those people who have just been diagnosed with early-stage MS. But what do patients who have tried the drug actually think? Anthony Dean, who we heard from earlier in the programme, was put on the original trials for the drug.
Well, when I was diagnosed in the first place, the first question I had was about what treatment was available. I'd done some research online, I'd Googled my symptoms, and I kind of had an idea of what I might be diagnosed with. But then on the back of it, I had looked up what would be available. After speaking to the consultant, it became obvious there were two options to me. Either take the standard course of beta interferon, which would have been done by an injection, or I was offered to take part in a trial. My first question was, how successful has the trial been so far? And was told that early indicators were that it was proven to be very successful. So I decided to go ahead with it, in a sense take the gamble, because I thought I had nothing else to lose. I was invited back a couple of months later into hospital for 5 days of an infusion of CAMPATH alongside steroids.
So you were diagnosed with MS, and then 3 months later you started this CAMPATH treatment, and then that was 1 week duration of the treatment in hospital.
That's right, and that was all the treatment that I had in my first year.
And what consequences were there of this treatment?
The treatment itself wasn't too bad. I was in hospital being well looked after. I felt a little bit sick, I think mainly from the steroids more so than the actual treatment itself. On the back of it, though, there is a side effect known as the CAMPATH rash. Essentially, you sort of break up in a reddish, purpley kind of rash. But again, other than looking a bit like Barney the dinosaur, there's nothing actually wrong with you. It just looks a bit strange to people who don't know what you've been doing. And
did you regain sensation in the left side of your body?
It's not a matter of that it will give you back sensation. Everything that I'd had, problems that I'd had in the past, had always come back. It's part of the relapsing remitting form of MS. It comes and then it goes again. So at the time, I wasn't actually suffering from any problems with MS. So I'd gone into hospital healthy and came out healthy. But since that point, I haven't had one symptom of MS.
So how long have you been MS-free?
That would be 10 years. 10 years this week.
And do you think that your diagnosis and then your subsequent treatment has changed your life in a tangible way that you might want to tell the listeners about?
I think it would be wrong to say that I've re-evaluated my life and seized the moment. It's not the kind of person I am. One of the things on the back of it is that I started to take my fitness a bit more seriously. I took up running about 5 years ago and run half marathons, which is good fun. And last month, in fact, I did 3 half marathons in a month in order to raise money for the Multiple Sclerosis Society. So far I've raised about £2,500.
Good on you. Anthony Dean, who's an MS sufferer in Cambridge, who was talking to Hannah.
So Campath offers some hope to multiple sclerosis sufferers, but might it be possible to entirely cure the disease in the future for all those that have MS? Steve Hauser is a neurologist at the University of California in San Francisco, and he joins us now. Hi there, Steve.
Good evening.
So MS can manifest itself either gradually or it can come on more suddenly, as we heard in Anthony's case. But how does this quite broad spectrum of the way that MS can work, how does this affect treatment and also management?
Yes, this is a very important point that you've just made. MS, like other chronic autoimmune inflammations, rheumatoid arthritis, for example, can be a benign, almost trivial illness in some people, and a very aggressive and life-changing illness in others. So the first important consideration is that the severity of MS is very broad. The second important point is that the important outcomes can play out not only over a year or two, but much more often over a decade or two or longer. And our experience with therapies generally involve just 2 years or at most 3 years of observation. So it's an inadequate window to really see the long-term outcomes that we all care so much about. For someone like Anthony, who began with numbness in a couple of fingers, we really want to know what the natural course is. We want to be able to predict the future in those individuals so that we can assess whether this will be a serious or a trivial problem, and also how aggressively we would want to treat.
Alistair was talking about the immune system kind of attacking the nervous system. Is that genetics that are involved in this? So, for example, did Anthony have a genetic predisposition to this immune system hyperactivity?
Well, most likely he does. But in general, the genetic architecture of multiple sclerosis is quite complex. This is not a simple genetic disease, as Huntington's disease is, for example, but is a problem where many different genes, most of which influence somehow the function of the immune system, work together to increase one's risk. However, most of the risk, we believe, is environmental. So this is a complex problem in which both genes and environment participate.
And what type of environmental factors are involved?
Well, we don't have a full understanding of those. We do believe that the disease has increased in frequency over the past 100 years, and that is certainly environmental and not genetic, because our genes don't change enough over just a few generations to account for this. We believe that vitamin D insufficiency that most people in the Western world have chronically is part of the story. A healthier, cleaner environment, perhaps with later exposure to the Epstein-Barr virus, might be another part of the story. And then there are some other associations that may not be causal, but that are related to one's risk of multiple sclerosis, especially smoking.
Thank you very much, Steve. So that was Steve Hauser from the University of California in San Francisco, and he'll be available later to answer some of the questions that we've had in from Twitter and also from Facebook.
Thanks, Hannah. Now, MS has a pattern of remission and relapse, as we've been hearing, and this is because the disease flares up periodically, which causes some damage to the nervous system, which then slowly repairs itself. But it doesn't always completely fix the damage that's been done, and this can lead to some progressive worsening of the symptoms. But Luke Lairson from the Scripps Research Institute in California has been looking for some drugs that might be able to stop and even reverse this. Hello, Luke.
Hello.
So tell us about the approach you've taken.
So we've sort of heard MS is a disease which is associated with primary demyelination of axons, which leads to neuronal dysfunction. And as you've just described, the disease is characterized by relapsing and remitting phases, and ultimately we get progression of disease. And what's known is that during the remitting phases of disease, there's a population of stem cell-derived cells termed oligodendrocyte precursor cells, which are recruited to sites of injury and subsequently differentiate to a mature cell that can remyelinate a damaged axon.
So just to translate this slightly, so you've got these stem cells sitting in the nervous system that are capable of giving rise to the same cells that make the myelin that gets attacked in the disease and which goes away during the inflammation, and that those stem cells can potentially give new cells to remyelinate and repair damage.
Exactly right. And so what's known from looking at the chronic lesions of MS patients, the histopathology of those lesions, is that during the progressive phases of disease, there's still an abundant presence of this precursor cell. However, they're found to be in this intermediate halted state of differentiation, so they don't fully mature to a cell that can repair the damaged axon.
So it's a bit like you're in the garage and you've got a car that needs repairing and there's all the spare parts there, but they're just not being put onto the vehicle.
And so exactly. So what people have sort of proposed for the last decade is that an effective complementary approach to the treatment of MS, in conjunction with immunosuppressive strategies that we've heard about, would be to identify agents that can directly induce the differentiation of those precursor cells, which are in this halted state of differentiation.
So how did you approach that? How did you do it?
The approach we've taken, which other people have proposed to do, is we used an unbiased high-throughput microscopy cell-based approach, where we took primary cells from rat optic nerve and then developed assay conditions where we could mimic that halted differentiation, and then screened against about 100,000 compounds to look for potential drug candidates that induce the differentiation to a myelin basic protein positive mature oligodendrocyte fate.
Basically, you grow some cells in the dish that could make myelin if they were so inclined. You then chuck on up to 100,000 different chemicals. So in other words, you're doing this many, many times to see if any of those chemicals make those cells go back into a state where they want to make myelin. And then you can go, aha, that might be a potential drug to repair lesions in MS.
Exactly, right. And so from this, we actually identified a number of compounds, several of which had not been characterized before, which belonged to a class of so-called neurotransmitter receptor modulating agents, which effectively induced OPC differentiation in vitro. And so we decided to fast-track the analysis of these compounds because a number of them are actually approved drugs which are known to be centrally acting, i.e. they can get into the spinal cord of the brain. And so they had the potential for rapid progression to clinical development.
What drugs did you find?
The most efficacious compound we identified was an approved drug called benztropine, which is currently used for the treatment of Parkinson's disease. And using pharmacology, we determined that the activity of this compound is dependent on antagonism of a specific neurotransmitter receptor, the muscarinic receptor.
In other words, by blocking up that receptor, it makes the cells become active.
Right, and that's consistent with a finding that was reported by an Italian group last year, where they showed that activation of that receptor actually induces the proliferation and inhibits differentiation of this precursor cell.
And have you got any evidence, at least in animals, if nothing else, that if you give this agent, that it can remedy the damage done in MS?
Once we identified this compound and realized that it was an FDA-approved drug that would work in the central nervous system, we decided to evaluate it in vitro and in vivo using mouse models. So in vitro, we showed that we could, in fact, remyelinate existing axons in a co-culture experiment. And then we looked at the drug's activity in two mouse models of demyelination, remyelination. The first one is a relapsing, remitting model, inflammatory model of MS known as the PLP-induced EAE model. And we found that benztropine had a dramatic effect at decreasing the clinical severity in this disease, with efficacy that was comparable to or better than existing standard of care immunosuppressive drugs. And we then went on to look at it in an additional model, which is a non-inflammatory toxicity model known as the Cooperzone model. And again, we found that the drug had a dramatic effect on enhancing the rate of remyelination in vivo in the mouse.
Every reason to be positive then. Luke, thank you. You're listening to The Naked Scientist with Chris Smith and with Hannah Critchlow. We're talking about multiple sclerosis. This week we have with us in the studio Professor Alistair Compston from Cambridge University. We also have Luke Lairson from the Scripps Institute and Steve Hauser, who's from UCSF.
So one question that's come in from Facebook, David Bailey has been in touch and he's asking something that I'm quite interested to find out the answer to as well. Are there any similarities between multiple sclerosis and other neurodegenerative diseases such as dementia?
The nervous system has got a limited number of ways in which it can complain, as it were, and progression is one of them. So many neurological diseases get worse over time, sadly. That's why they have a poor reputation. There is a view now, and it's quite a popular view, that diseases like Alzheimer's disease, Parkinson's disease that we were just hearing about, are also inflammatory diseases. And I've been arguing earlier in the programme that multiple sclerosis is primarily an inflammatory disease. The crucial point here, Hannah, though, is whether the inflammation that happens in Alzheimer's disease, Parkinson's disease, is a reaction to the damage that has already occurred, something which amplifies the problem, or whether it is the primary driver. And multiple sclerosis, in my view, is a disease that is driven by inflammatory processes, not something in which these are just a reaction to another primary event.
And we heard quite a few months ago now, we had Belinda Lennox from Oxford on air, and she was talking about some findings where the immune system was actually attacking proteins in the brain, and that was giving rise to psychosis as well. So the immune system could be involved in a lot of different disorders with the brain.
So neuroimmunology, the discipline of studying immunology in the brain, is an emerging discipline. And one of the really exciting discoveries is that a number of diseases that previously were completely mysterious are in fact driven by antibodies or immunological processes directed against receptors, ion channels in the brain. A whole new class of diseases has been discovered, of which psychosis is one.
Thank you very much, Alistair. Chris Cooper has been in touch via Facebook. And again, Alistair, I think this one might be for you. He's asking whether MS is definitely an autoimmune problem. And he's asking whether Campath will actually work definitely in the long term.
He's asking a very sensible and a reasonable question, which is that it's all very well for medical scientists and doctors to promote particular treatments, but do these really work in the long term? Is the immunological hypothesis correct? I think that the problem is that it hasn't really been tested until recently, by which I mean that patients have not been treated at the right stage with drugs that really do the job. Now, in my view, but I would say this, Campath is a good way of testing the hypothesis. You've heard from Anthony Dean that 10 years on, he is normal, running marathons and so on, and that's great. That's roughly the experience that we've had with most of the patients who we've treated. We've followed them, or we've looked after them now for up to 14 years, and so far we are very encouraged, as are they, by the lack of any progress. Indeed, many of them are now better than they were when we began. So I think if you do the right experiment, if I can put it in those slightly hard terms, of using a drug that really works at the right stage of the illness, then you can see whether this is going to have a long-term effect. And so far, so good.
Thank you very much, Alistair.
Thank you, Hannah. Bridget is with us. Hello, Bridget.
Hello.
Go ahead. What would you like to ask the team?
What it is my husband got multiple sclerosis in his late teens, and he was to go on to be a professional footballer, but he used to be ever so good one week, and he could do everything, and then another week he couldn't run properly. His legs used to go together, and it was awful to watch, really. We got married anyhow, and he started to fall down, and that when he was 34, and we had 3 children at this stage. And he was diagnosed when he was 35. Well, the question is this hereditary for one thing?
Let's first of all put that to Steve.
We really do not understand why your husband developed multiple sclerosis. The wonderful progress that Professor Compston discussed earlier in this session really gives us hope that in the future we might understand MS in a simpler way. We know that genetics and our inheritance does predispose some of us more than others to developing MS. But MS is not a purely or even a predominantly hereditary disease.
Thank you very much, Stephen. Alistair, have you got anything to add to this?
Well, only really to reiterate what Steve has said, that knowing about the genetics of multiple sclerosis helps us as medical scientists to understand the nature of the problem, but it's not a cause for worry for individual people because the risks to close relatives are very, very low, except in the one situation of an identical twin. But the genetics is about understanding what's going on, not about counselling or other applications.
So, say, for example, my grandma had multiple sclerosis. So what's the chance of me then developing multiple sclerosis compared to Chris, whose grandparent didn't?
Well, I'm sorry to hear about your granny, Hannah, but it does mean that you are very slightly more likely than the average person to develop the illness. Shall we say 1 in 500 people will develop multiple sclerosis. And if you've got a first-degree relative who has or had the illness, then your individual risk is slightly increased. But it is still very low. And we have figures for the granddaughter of a woman who had the illness in life, and you can be reassured that this risk is down at under 1%.
Thank you, Alistair. Luke, Danny has got in touch on Facebook, and he's saying, is it possible to regrow the myelin sheath around axons with stem cells? So, in other words, the stem cells that you're finding how to reactivate, have you got evidence that you can, in a human, remyelinate damaged nerves?
With our drug, we don't have the in vivo human data, of course, yet. We'll need clinical evaluation for that. But there is in vitro and in vivo data, both in rodent and man, that these stem cells are capable of repairing damaged axons and remyelinating. So, yes, there is data for that.
Thanks ever so much, Luke. And Alistair, I believe that you've been working with someone who's also working on regrowing myelin sheath.
Well, we read Luke's work recently in the journal Nature with great interest, and it's really fantastic that there are now agents being identified, albeit still in animal models, which have the potential to enhance remyelination. So as medical scientists, neurologists, we're very optimistic that molecules, drugs, if you like, will become available which can help the body to repair itself, to improve, as we say, endogenous remyelination. And the anticholinergic drug that Luke discussed is one such, and there are others. So in our own university here in Cambridge, Robin Franklin has identified some molecules which are in the same general family of improving endogenous remyelination.
That is it for this week, but thank you very much to our guests, Anthony Dean, Alistair Compston, Stephen Hauser and Luke Lairson. Thank you also to Hannah Critchlow for joining in, and the production this week was by Kate Lamble.